you roll 3 fair 6-sided dice, and for an integer n, you define the event. So these are the results of the 3 dice. So this is the result of the first die, the result of the second die, the result of the third die. And what we are saying the event of interest is when their sum is equal to n. So in other words, what is the probability when we throw 3 die that their sum is equal to n? And we want to be able to answer this for any n. So what's the probability that their sum is equal to 3? That their sum is equal to 5, right? So of course it needs to be a number between 3 and 18, because there's no way to get other results. The smallest you can get is 3 1s, and the largest is 3 6s, right? So what is the probability of getting an n? So let's look at this carefully. So again, the sample space. So our sample space is going to be all the possible results that we can have, right? All the possible outcomes. So in this case, it's going to be equal to all the I, j, k, such that, let's write this in a different way, I, j, and k, all 3 of them belong to the set 1, 2, 3, 4, 5, and 6. Right? So it's going to be all the ones where you can put any number between 1 and 6 here, 1 and 6 here, and 1 and 6 here. So what is the size of the sample space? Well, you have 6 possibilities for the first die, 6 possibilities for the second die, and 6 possibilities for the third die. And so that gives you 36 times 6, which is going to be 216. So these are all the possibilities, right? And what we are interested in is in that an, which was the set of all the ijk that sum up to n, right? And so since the die is fair, and these are disjoint events, then the probability of an is going to be equal to the size of this set, divided by the size of the sample space, and so it's going to be equal to the size of an divided by 216. So what this means is that to solve this problem, we essentially need to solve a counting problem. So we need to count how many ways can the sum of 3 die give you a certain number n. And we did this already. So in lecture 12, we used generating functions to obtain a closed form for this. So we obtained this over here. And so with that, we essentially solved the problem. So the answer to this is just going to be this here divided by 216, and then you can just replace n by whatever number between 3 and 18. And the whole point of, and so go, of course, see that lecture so that you can see how you solve this, and that's how you then solve this problem here. And the whole point of this video then is to just showcase that many problems in probability, they're gonna end up boiling down to some type of counting problem. And we've been doing a bunch of ways of solving counting problems, so you might need to be able to use those techniques to solve probability questions. So many probability questions, you're going to end up having to count something complicated, and maybe you need to use generating functions or recursions or anything, induction, any technique that you've seen until now, and then you need to be able to reinterpret it into what does it mean in terms of probabilities.